Okay, students, in this video, I will teach you thermal conductivity. In earlier video, we discussed about electrical conductivity. So next, just after electrical conductivity, we will be discussing about thermal conductivity. So let us see what is thermal conductivity. Okay. Now, we'll try to find out expression for thermal conductivity. As we have discussed about electrical conductivity, the electrical conductivity as obtained is sigma is equal to n e square lambda v 6 kb t. Now let us find an expression for thermal conductivity. And as we know, the conduction of heat in a metal is mostly through free electrons. Free electrons are responsible for the conduction of heat in a metal. So this is important point. Let us see some of the behavior of flow of heat with the help of electrons. Let us consider plane AB. AB is a plane, and the plane is normal to the direction of flow of heat. The distance between two planes is twice lambda. Is another plane CD and EF. Okay, we are considering another two planes CD at higher temperature T1 and EF at lower temperature T2, so that the heat flows from T1 to T2. T1 is greater than T2. So the distance between two planes from AB plane is the distance between two planes CD and EF is twice lambda, where lambda is a mean free path. Now one point should be noted that the kinetic energy of molecules at the hotter end, which was the hotter end? The AB is the conductor, its hotter end is towards the side of CD. AB যদি conductor হয় তেতিয়াহ'লে ইয়াৰ hot side to CD ফালে থাকিব. And EF is comparatively colder than CD, so the side towards EF will be colder end. Okay, so it is clear that the hotter end will be towards CD and colder end will be towards EF. EF is at some lower temperature. In collision, the electrons near CD will lose kinetic energy. At the same time, the electrons near EF, this conductor, will gain kinetic energy. Okay. Now, one important point should be noted that the conduction of heat through the element is due to the transference of energy. So let us see how it transfers from one side to other side. Okay. Okay. Let us AB is a conductor and CD is here. EF is here, and lambda is a path, which is the mean free path. Both the planes EF and CD parallel planes are at a distance lambda from the conductor AB. So its temperature is T1, its temperature is T2. So as T1 is greater than T2, T2 temperature to T1 is greater than T2. That is, heat will flow from this side to that side. Okay. So we are considering this conductor and heat flows in this direction. Heat is flowing from this to this. So all the electrons towards this side will have some higher kinetic energy, and all the electrons towards EF will have some lower kinetic energy. That is, during collision, the electrons towards this side will lose kinetic energy, and electrons towards that side will gain kinetic energy. So we have to find the transfer of energy. So heat will be transferred from this side to that side. So let us find out the net ট্ৰেন্সফাৰ অফ এনাৰ্জি, কিমান হিট ট্ৰেন্সফাৰ হয় এইফালৰ পৰা সেইফালে, সেইটো আমি উলিয়াব লাগে। So let V1 V2, V1 is the velocity of electrons towards hotter side and V2 is the velocity of electron towards colder side, right? Velocity of electron towards CD. CD follows the hot electrons, and velocity of electrons, V2 is the velocity of electrons towards EF. These are the velocities of electrons of the conductor AB. V1 is the velocity of electrons having some higher kinetic energy, and V2 is the velocity of electron with lower kinetic energy. Okay. Therefore, half m V1 square is equal 3/2 kb T1. Okay. So T1 is the temperature of this site. So the kinetic energy of the electrons at the hotter end, hotter site, will follow the kinetic theory rules. Then we will get this, because this kinetic energy is directly proportional to T1. Okay. Then 3/2 kb is the constant of proportionality. So we get like this, or and half m V2 square. So electrons with colder end having velocity V2, 3/2 kb will be same T2. Okay. Now, if small n is the number of electrons per unit volume. So if small n is the number of electrons per unit volume, then the number of electrons crossing per unit area of AB per second is given by n/6 V. Okay, where here V is the mean velocity crossing AB. That is this AB. AB is the area of the conductor, area cross section of the conductor. Now, heat transferred from left to right, from left side to right side. What is the amount of heat transfer? So left side is this one, right side is this one. So we have to multiply by total number of electron. Okay, this is only due to for single electron. This is the amount, and this is the total number of electron. So we have to multiply by this. So n6 V this is 3 by 2 kV T1. From right to left, from right to left, from right side to left side will be this one, is equal n by 6 V into 3 by 2 kV T2, this value. This is the amount of heat transferred from left side to right side. Okay, this is the amount of heat transferred from right side to left side. Okay, so net amount of heat transferred, net heat transfer is equal, because this T2 is greater than T1, so this minus this N6V 3 by 2 kV is this minus this T1 minus T2. Okay, so 2 1 by 4 NV kV T1 minus T2, right? So this is the net amount of heat transferred from left side to right side. So by definition, the conductivity is given by K net heat transfer divided by temperature gradient. So what is the temperature gradient? Temperature gradient is the T1 minus T2 divided by twice lambda. Okay, the total path is equal to, this distance is equal to lambda plus lambda twice 2 lambda. Okay, so temperature gradient, that is change of temperature with respect to distance. So change of temperature is T1 minus T2 divided by per unit distance divided by total distance is twice lambda. So this is called temperature gradient. So net heat transfer is this one. So 1 by 4 N V kV T1 minus T2, right? So twice lambda T1 minus T2 will be cancelled. 1 by 4 into twice lambda and V kV. Okay, 1 by 2 lambda and V kV. Okay. So this expression gives the thermal conductivity. Okay. So we get the value of thermal conductivity K is equal to half lambda and V kV. Okay. So next point is that Weidmann-French law. According to the statement, the ratio of thermal conductivity K to the electrical conductivity sigma is a constant. That is, this ratio K by sigma is a constant for all metals and is proportional to the absolute temperature. So if you put the value of K, that is thermal conductivity, as half lambda N V kV, and value of sigma as N E square lambda V divided by 6 kVT. Now after simplification we will get this value, 3 kV whole square. 3 kV whole square, kV will be whole square, E will be whole square. Okay, kV by E whole square T. Okay, so kV by E whole square T